Okay, I'm going to set my coordinates up here. I've got y-axis and an x-axis, and this time I'm going to draw two straight lines on it. I'm going to draw a red line and I'm going to draw a blue line as well. And of course, as soon as you get two lines on a graph, the first thing you ask is where they cross. So I'm just going to investigate that. If we've got two lines, how do we describe them? Well, we've got y equals mx plus c, which is our standard format for a straight line. But we've got two expressions. We've got y equals m1x plus c1, m1 being the slope of the first line and c1 being the intercept of the first line, and we've got y equals m2x plus c2. Okay, so how do we figure out where they meet? Well, we know that when they meet, the x coordinates match. We don't necessarily know where that is, but we know that this x value and this x value are going to be the same, and also the y values are going to be the same, because at that point the x-axis matches, and the x-axis and the y-axis match. That's what it means to meet at a point. So I'm going to solve these equations here. I can just set that equal to that. I can say m1x plus c1 equals m2x plus c2. And if you'll notice, we know all these terms except for the x. We're trying to find the x because that x value it's negative here, of course, because I've come back. This x at the crossing value, we don't know what that is. We're trying to find that. But we know everything else in this formula. We know m1 because it's the formula of the first line. Of course, we don't know the x because that's what we're trying to find. We know that, we know that, we don't know that, we know that. So we've got this nice system here where we know everything except for one thing, and it's x that we don't know, but it's in this peculiar format. So what I'm going to do is take that m2 over the other side. We've got m1x minus m2x equals, and I'm going to take that c1 over the other side as well. So it's c2 minus c1. And that keeps on happening and I don't know why. So that's x times m1 minus m2 equals c2 minus c1. X equals c2 minus c1 upon m1 minus m2. Now I'll tell you what, that's annoying, because look, this one is a 2 minus a 1 and that's a 1 minus a 2, and that'll drive you nuts. So I'm going to redefine that. I'm going to say it's minus c2 minus c1 over m2 minus m1. There you go, just going to define it like that. So that's my point of crossing, or that's the x-axis anyway. So you'll remember that I've got two lines. I've got y equals m1x plus c1, and I've got also for the second line m2x plus c2, and we know the value of x at the crossing point. So what we need to do is to figure out what the y value of the crossing point is. I could write it on if I wanted. I could write that on using this formula here if I wanted. I'll put that in brackets. There we go. Okay, well, let's check it out. Let's see what happens if I just substitute it in. So y equals, from the first line, m1x, and we know what that is. It's minus c2 minus c1 upon m2 minus m1. That formula there just being this one here. Get my brackets tangled up, plus c1. I'll just check what I've got here. I've got m1. I'm using this formula here to get the value of y. m1x, and so this thing here is x plus c1. Alright, so it's going to be c1 for that minus m1 times c2 minus c1 over m2 minus m1. There you go. And so that's my value of y at the crossing point. I could just leave it like that, but a good mathematician always checks. And we've got another equation here. There he is. We've got another equation here to get y. So what I'm going to do, what I'm going to do is, I've used that equation there to get y. I'm going to use this equation. It should be the same value, because where the lines cross, the value of y is the same, because y might be, here we go, y is decreasing, 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 and y is increasing, 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 but at the crossing point the two values of y are the same. So what I'm going to do is substitute that value of x there into this equation here, not that one because we've done it and got that answer there, this equation. So just write it out, y equals m2x plus c2 equals minus m2 times x, c2 minus c1 over m2 minus m1 plus c2. It doesn't look to be the same, does it? It doesn't look to be the same. It doesn't look to be the same. So I've got two different values for y and they don't look to be the same. So let's just I'm going to call it ya equals the one that we got first, c1 minus m1. Oh, excuse me. m1 c2 minus c1 over m2 minus m1. And I've got yb, which is this one here, which is c2 minus m2 c2 minus c1 over m2 minus m1. Okay, and I'm going to see what ya minus yb is, and it better be 0 because that will mean that they're both the same, and so everything will check out, and if it doesn't, I've screwed up. Okay, well let's just try that then. Let's put that over there. We've got ya, which is c1 minus m1 c2 minus c1 over m2 minus m1 minus c2 plus, you see I'm subtracting yb, so that c2 is minus there, minus a minus is a plus, m2 c2 minus c1 over m2 minus m1. Put that in brackets, okay? So that equals c1 minus c2, oops, that should be red, c1 minus c2, which is there, go back to black, plus m2 c2 minus c1 over m2 minus m1, which is this one here, that's there, and that this is the only term I haven't got, I'm going to put that there, minus, go back to black, minus m1 c2 minus c1 over m2 minus m1. Okay, so it's c1 minus c2 plus, well, we've got something peculiar here. We've got m2 times this c over m business, and we've got m1 minus the same thing. This thing in brackets here, it's the same for both ones. So it's m2 minus m1 times c2 minus c1 over m2 minus m1. Okay, all I've done is factorize it. I'm noticing it's m2 times something minus m1 times something, and I've just written the something there times m2 minus m1. That's right distributivity that we talked about in screencast something. Okay, put that in brackets as well because I feel like it. c1 minus c2 plus, and look, now you can see what's going to happen. Look, that cancels that. Isn't that nice? Plus c2 minus c1, because when we cancel the top and the bottom there, all we're left with is that, which equals 0. Ha 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 ha. Okay, so now we've got this nice way of thinking. We've got, just to summarize exactly what we've got, we've got y equals m1x plus c1, we've got y equals m2x plus c2, and we seek the crossing point, the crossing point, the intersection, I guess, the mathematic point. Okay, which is at x equals, what was it? Oh, there it is. Look, need to pinch in a little bit. It's this thing here, minus c2 minus c1 over m2 minus m1. Just a minute. I think I've zoomed in a bit too far here. Minus C2 minus C1 over M2 minus M1, and y was equal to, well, I've got it up here. We'll use this one here, C1 minus M1 times that thing. C1 minus M1, C2 minus C1 over M2 minus M1. I think that's right. C1, oh there it is, look, C1 minus M1, C2 minus C1, which is there. Okay, and there it is, and we verified that that was right because we substituted the value for x into the second equation for the line, for the second line, and we got the same value, or at least we got the difference equal to 0 after some fooling around. So there we go, that's quite nice. There is a slight lacuna here, which is that all this only works if M2 is not equal to M1, because if M1 equals M2 we've got a problem because we're dividing by 0, which you can't do. I know I've gone over time, and I'm at 11 minutes now, but it's pretty obvious that if we've got two lines of slope M1 and M2, they're the two slopes of the lines, and if M1 equals M2, the two lines are parallel. We covered this ages ago. The two lines are parallel. Vroom, vroom. There you go. Two lines, and all they've done is it's just been translated vertically. And of course, they don't cross. They don't cross, and so you're trying to find the position of a point that doesn't exist, and then of course you're going to be in trouble. And the way that manifests itself is that you're trying to divide by 0. So in this case, dividing by 0 tells you something, and it tells you that the two slopes are the same, and you've got parallel lines. They're like this. They never meet. It's like railway tracks, and they don't meet. Okay, I'm going to stop there. Stop.